This talk is about IMoG's tooling prototype. We created a tooling prototype for IMoG to evaluate our modeling methodology. The scope of the prototype is the functional perspective. The prototype was limited to this scope because the effort for consistent tooling between all perspectives within this project was too high. A sophisticated tooling is left open for an industrial development after this project. The functional perspective is based on the well-known feature models. As already mentioned in the talk about the functional perspective, we adjusted the meta model to our needs in the context of public committee-based road mapping. This includes the differentiation of features and functions, and the addition of a description, an abstraction level, and various attributes to each block. The abstraction level is primarily used for filtering purposes. A configuration of the functional perspective is defined similarly to feature models. However, configurations are currently not supported in the prototype. We consider two approaches in achieving tooling support for the functional perspective. First, translating or implementing IMoG into an existing modeling language like UML or SysML to take advantage of the existing tools. This approach is faster and eases the integration of IMoG into the internal modeling processes of the industry companies, or by implementing a dedicated tooling prototype for IMoG by ourselves. This approach takes more effort but brings a more elegant solution with a better learnability curve and a better user experience. For the purpose of an IMoG evaluation, we choose the latter approach, which promises a better user experience and less distortion in an evaluation. The reasoning for this decision can be further underlined by discussing what kind of benefit we expect from using different kinds of tooling support for IMoG in a committee. Let's take a look at the following figure. The horizontal axis represents the amount of tooling support in the committee, ranging from no tooling support over to generic tooling support to a dedicated tooling support. The vertical axis represents the expected benefit of IMoG in a committee. In general, the more the tooling is designed around its application, the higher is the expected acceptance. With no tooling support used in the committee, the expectation is that IMoG generates a huge modeling overhead. The models would be drawn and the committee would need guidance on how and what to model. An IMoG expert would be essentially required to create the models. The strong separation of perspectives and abstraction levels would make it hard to remain efficient. This IMoG would be barely accepted in the committee. Only the use of IMoG's process would provide a guidance and would lead to a slightly positive benefit in innovation model. When IMoG is translated to a generic modeling language like UML or SysML and supported by a generic tooling, then IMoG would provide a positive benefit to the committee. IMoG would be roughly supported by different types of diagrams for perspective and view separation, but the modeling elements would not perfectly fit and would be cumbersome to handle. It would take the committee some time learning on how to handle the models. Only an expert would be able to set up IMoG in the external tool such that it would be usable by others. All in all, the tooling would only have a moderate acceptance in the committee. When fully supported by the dedicated tooling approach, IMoG would make innovation modeling efficient. The dedicated tooling would support templates for perspectives and mapping views between different models. Each modeling element would have a dedicated interface corresponding for its considered use. There would be hardly any learning overhead and the good user experience would be motivating. The tooling would understand IMoG's process and would request the necessary inputs from the user. A new user would be guided through the tooling and would not have to understand IMoG to the degree of an expert to provide meaningful content. IMoG together with its tooling would significantly reduce the time required for innovation modeling and would help to understand the innovation efficiently. The tooling would have a high acceptance in the committee. So let's take a look at the tooling. The tooling prototype is publicly available under the given link here. I would like to thank the University of Ulm for providing their tool Iris that we used as a basis for our IMoG prototype. Okay, let's open the tooling. In the following, the model of the functional perspective of an e-scooter is created in the prototype to present the features of the tooling. The tool runs in the browser and this is the first view you will see when opening it. Let's take a look at the user interface first. It contains a modeling editor in the center, one sidebar on the left, and one on the right side of the tool. An IMoG perspectives toolbar and a menu toolbar. The entry file in the menu bar can be used for creating new models, saving models, and loading models. The entry examples can be used for loading example models like the e-scooter model. The undo and redo buttons and the entry settings can be used for changing the user interface. For example, the grid size of the model editor. The menu bar additionally includes toggles to open and close the sidebar and the visibility sidebar on the left and right side of the editor. The sidebar on the left is used to display and manipulate information about selected model elements, for tracking of changes in model history, edit history, and for presenting the keyboard and mouse shortcuts. It is possible to view older model states through the model history. The visibility sidebar on the right can be used to filter model elements and highlight them. For example, it is possible to highlight all function blocks in a green color while hiding all mandatory relations. The IMoG Perspectives toolbar allows to select the current perspective and view. The functional perspective is, for example, currently selected. It is possible to swap to different perspectives in the prototype, but the model editor is disabled for the other perspectives. The model editor can be used to create the functional perspective model, like the e-scooter model. The root feature of the e-scooter model can be created by using the context menu of the model editor and by entering its name, providing mobility with an e-scooter. Each feature and function is represented by colored blocks. Each block can be selected to operate with, like by renaming them, resizing them, changing their type and color, or duplicate them. When selected, the tab IMoG in the sidebar will present further information about the block. This information can be manipulated, giving the block a description, changing their prototype, or setting their abstraction level. After adding further features and functions to the model, the features and functions can be related with each other. A relation can be created by selecting a block, choosing a relation from the relation toolbar under the block, and then clicking on the target block. All 8 relations of the functional perspective can be used, changed, and enriched with labels and information. These include the mandatory relation, the optional relation, the requires constraint relation, the excludes constraint relation, the custom relation, the alternative relation, the OR relation with a given cardinality, and the multidirectional custom relation. Let's assume that we add further features, functions, and relations to the e-scooter model. We will shortcut the creation here by loading the e-scooter models from the examples. We can see 4 layers of features and functions. The first layer contains the root feature, the yellow block. The second layer, the context level features, the yellow blocks. The third layer, the system level functions, the green blocks. And the last layer, the component level functions, the purple blocks. These layers are connected via the mentioned relations. We can see the block properties in the sidebar and, for example, add the stereotype innovation to the root block. When we go to the history sidebar, we can take a look at the edit history. Let's jump back a few states. Here we can see a read-only model of one of its preceding states, while the relations are added to the example. Let's jump back to the current state. Let's decide to filter out the component level blocks. This can be done in the visibility sidebar by removing the checkmark from the component level checkbox. Let's further highlight all mandatory relations in red. This can be done by choosing relation types as a highlighting category and choosing the color red for the appearing color box for mandatory relations. And that is all I wanted to show. Let's discuss shortly the evaluation of the prototype during the project time. We have conducted a user experience evaluation with 2 other researchers. We gave them some predefined tasks to learn handling the user interface, like creating some blocks, changing their prototypes, relating blocks with each other, saving and loading models, and using the filtering features. Afterwards, they had to redraw a model given on paper to identify the use of the tooling. Furthermore, we asked them to open an example model and ask some more challenging questions about the model to identify if they understood what the model was meant to present. Finally, we did a round of structural interviews with them regarding their user experience. The prototype was overall evaluated as fast responding and easy to use. We experienced the limitation of missing the other perspectives of IMoG in the prototype. Nonetheless, our prototype demonstrated the large potential of a dedicated tooling approach for any IMoG-related project by not bothering the user with cumbersome interactions. Thus, we encourage the reader, other industry partners or communities to try out IMoG and its tooling prototype in their committee.